Hello everyone, welcome to KS Math Academy. In this session, you will learn the most expected questions from the chapter Relation and Functions from the class 12 CBSE. And these two data are very important. The number of reflexive relations on a set with n elements is 2 to the power of n into n minus 1, and at the same time number of symmetric relations are 2 to the power of n into n plus 1 divided by 2. Next, look at this question. So, in this question, we are given with a set A, and here a relation is also given to us. We have to find the type of the relation. Here, in this case, since our data 2, 2 and 3, 3, 4, 4 are not available in the relation, so it is not reflexive. Whereas 2, 3 is available and 3, 2 is also available in the relation. So we can say the relation is symmetric. So option B is the correct answer. Look at this question. This type of question is very famous in board exams. Let's say x is equal to 1, 2, 3 and a relation R is defined and it is given to us. Find the minimum ordered pair which should be added in a relation R to make it reflexive and symmetric. So here R is given 1, 3, 2, 2, 3, 2. So ordered pair to be added we have to identify. Then for make it reflexive, then 1, 1 and 3, 3 has to be added to make it reflexive. And 3, 1 and 2, 3. These two data 3, 1 and 2, 3 is added to make it symmetric. So finally you can combine your answer as the added data should be these data. So 1, 1, 3, 3, 3, 1 and 2, 3. So look at your option. So C is our answer. In this question, if R is equal to x, y and x and y belongs to Z and the data given the relation is x square plus y square is lesser than or equal to 4 is in a relation, is a relation in the set. So we are asked to find the domain value. So here we are given with the relation x square plus y square is lesser than or equal to 4. So find your y data. So y is lesser than or equal to root of 4 minus x square. To find your domain value, this data should be greater than or equal to 0. So for finding the domain, 4 minus x square should be greater than or equal to 0. So 4 is greater than or equal to x square. So our x value lies between minus 2 and plus 2. So our domain is now minus 2. So minus 2, minus 1, 0, 1 and 2. So this is our answer. Look at this question. Consider the function f is r plus 2 minus 9 to infinity given by f of x is given to us. Check whether it is bijective or not. That is our question. Bijective in the sense, what is the meaning? You know very well. For bijective case, it should be 1 to 1 as well as on to. So you have to check for both. So for checking 1 to 1, so f of x is given to us, that is 5x square plus 6x minus 9. That is our question here. So now you can use this. So f of x1 is equal to f of x2. Then our function is 1 to 1. So check for that. So 5x1 square plus 6x1 minus 9 is equal to 5x2 square plus 6x2 minus 9. So x1 is equal to x2. So our given function f is 1 to 1. Next, checking for on to checking. So now we are given with the equation, the same equation y plus 6x minus 9. So you rearrange your equation. So 5x square plus 6x minus 9 minus y is equal to 0. So you can write like this. Minus of 9 plus y is equal to 0. To solve for the x value, use your quadratic equation formula. So minus b plus or minus root of b square minus 4ac by 2. So here a is 5, b is 6 and c is minus of 9 plus y. So x value is minus 6 plus or minus root of 36 plus 20 times 9 plus y divided by 10. And here look at your question. Here it is given with r plus. So since the domain is r plus, you have to take your data inside, that has to be taken with your value. So now you have to simplify this data. This will be 36 plus 180 plus 20y divided by 10, and you can take your 2 outside. Root of 54 plus 5y divided by 10 here. So, and we know very well in the question, since the domain is r plus, so r plus, then it has to be only with the positive data. So the data within your square root should be greater than and equal to 0. So 54 plus 5y is greater than and equal to 0. So 5y is greater than and equal to minus 54, and y is greater than and equal to minus 10.8. So our codomain value was now minus 9 to infinity. So you can say your signal is function is onto function. So f is onto. So both the conditions are getting satisfied, 1 to 1 as well as onto. So our function is bijective function. Now in this question, the function is given with 1 by 2 comma minus 1 by 2 comma plus 1 by 2. This is our input side, and output side is minus 5 by 2 to plus 5 by 2. Defined by the function sine inverse of 3x minus 4x cube. So you have to check for the condition options. So now you have to consider your f of x is sine inverse of 3x minus 4x cube. This is our given data. Let us consider x is equal to sine theta. So our function becomes f of x is equal to sine inverse of 3 sine theta minus 4 sine cube theta. So this is the formula of sine 3 theta, sine inverse of sine 3 theta. So now our f of x is nothing but our 3 theta. So for checking your 1 to 1 and on to functions, you have to go with. So if f of x is equal to f of y, then what is our signal? 3 times sine inverse of x is equal to 3 times sine inverse of y. So you can say x is equal to y. That is the case. Okay. So now our function is 1 to 1. And for checking the onto, we know y is equal to 3 times sine inverse of x. And if I am supplying the value of x, then this will be y sine of y by 3. And we know very well if x belongs to the r, then y also belongs to r. So our function is onto. So these two conditions are satisfied. 1 to 1 as well as onto is getting satisfied for this given function. So our function is bijective in nature. So what is our option here? It's D. Read this question. The function is r to r, real number to real number. Be given by f of x is this symbol, this bracket within x is greatest integer function. So greatest integer x square plus greatest integer of x plus 1 minus 3. So then we have to find out this. So here this is the greatest integer function. So for different values of x, we will have some values of f of x. So we can say always this function, this greatest integer function f of x is will be always an integer. So we can say our function f is many to 1. And similarly, if you consider the codomain value, the codomain is mapped with at most one element in the domain. That is, you can say like this. If x belongs to the real number, if your input signal x belongs to the real number, and our output signal f of x belongs to the integer, greatest integer. Here greatest integer function is given to us. So f of x belongs to integer. So our f of function f is into function. So combination is many to 1 and into. So what is our option? Many to 1 and into is our option. Show that the relation S in the set R of real numbers is defined by S A comma B. A is lesser than or equal to B cube. Both data A and B belongs to the real number. So we have to prove neither reflexive nor symmetric nor transitive. So we will go with one by one. So you can take real number. Both the numbers are real number. So you can consider the data 1 by 2. A is 1 by 2 and B is 1 by 2. So 1 by 2 is lesser than or equal to 1 by 2 the whole cube for checking your reflexive. But this is not true. So here the set relation is given with the letter S. So you have to use that. So S is not reflexive. Next condition. Next go with for symmetric. So in the case of symmetric, I can take 1 is lesser than or equal to 3 cube. But it is belongs to the function S. Sorry, relation S. And here this data 3 comma 1, that is 3 cube. 3 is not lesser than or equal to 1 cube. So this is not satisfied. This condition is not satisfied. So you can say like this. So 1 comma 3 is in the relation S and 3 comma 1 is not in the relation S. So the S is not symmetric. And coming to the third condition, transitive. So here relation is given with the letter S. So you are using your letter S always while doing your answer. So you can consider your data 10 is lesser than and equal to 3 cube. Okay, 10 is lesser than and equal to 3 cube, and you can consider 3 is lesser than and equal to 2 cube. These two conditions are satisfied. But for transitive, this is not satisfying. So here this data is not get satisfied. So you can write your signal like this. 10 comma 3 belongs to S and your 3 comma 2 is also belongs to S and your 10 comma 2 is not belongs to S. So you can write your answer as S is not transitive. So look at your question and conclude your answer properly. We have to show that all the three conditions has to be given in your final answer. So you can write your final answer as, so hence S is neither reflexive nor symmetric and nor transitive. In this problem, relation R on a set A is given with 1, 2, 3, 4, 5. Is defined by the relation xy and modulus of x square minus y square is lesser than 8. Check whether relation is reflexive, symmetric or transitive. So here you consider for checking the reflexive, both the data should be same. So modulus of x square minus x square always equal to 0, but this data is lesser than 8, the condition gets satisfied. And also this data, that is this data is satisfied. So x comma x is belongs to the relation R and for all values of x belongs to the set A. What is our set A? 1 to 5. So you can say your R is reflexive. And for checking the symmetric data, you have to check for x and y has to be interchanged. So modulus of x square minus y square is lesser than 8 in the sense, then it implies that, you can write, implies that modulus of y square minus x square is also lesser than 8. That is your x and y both belongs to the relation R. So you can, for all values of x and y, this belongs to the set A. You can write like this. So belongs to the set A. So you can conclude your answer R is symmetric. And for checking the third one, transitive, we can assume our data x is equal to 2, y is equal to 3 and z is equal to 4. Consider your data. So modulus of 2 square minus 3 square is lesser than 8. This is true. And modulus of 3 square minus 4 square is lesser than 8. This is also true. But here this 2 square minus 4 square is not lesser than 8. This this is not lesser than 8. So you can write your answer as here 2 comma 3 is belongs to the R and 3 comma 4 is also belongs to R, whereas 2 comma 4 is not belongs to R. So you can finally write your answer R is not transitive. So you can combinedly write your answer. The given R is reflexive, symmetric but not transitive. Look at this problem. A relation R is defined on n cross n. N is natural number. And a relation is given with A comma B, relation with C comma D, where the data is A by C is equal to B by D. Show that R is an equivalence relation. Equivalence relationship in the sense it has to be satisfied with all the three. So reflexive, symmetric and transitive. So you got to go for the condition one by one. So we know here the condition A by C is equal to B by D. For checking the reflexive, this is A by A is equal to B by B. So we can write our relation as this way. So A comma B is with the relation R is A comma B itself. So it belongs to n cross n. That is what we have in our question, n cross n. So that you can find your answer R is reflexive in nature. And similarly, considering for the next condition, so we know, let us consider A comma B is relation with C comma D. And for all values of A, B, C, D belongs to n cross n. So you can write like this, and then you can write your data as A by C is equal to, so you can write your answer A by C is equal to B by D, which implies, according to our condition checking, C by A is equal to D by B. So you can write your data as C comma D is relation with A comma B. So you can write your answer R is symmetric in nature. And coming for transitive checking, you can consider like this. So let A, B with the relation C, D, and next C comma D is in relation with E comma F, and you have to remember for all the values, okay, for all the values of A, B, C, D and E, F, all are for all the values of A, B, C, D and E, F belongs to the natural numbers. So n cross n. So you can write your answer as A by C is equal to B by D for the first condition. And for the second condition, for this condition you can write it as C by E is equal to D by F. While combining these two, so A by C into C by E, which is equal to B by D into D by F. So you can write your answer as, so you can write your answer A by E is equal to B by F. So which implies that is A comma B with the relation with E comma F. So R is transitive. So all the three conditions are satisfied. So you can write your given R is equivalence relation. Read this problem. Function R to R, f of x is 4x plus 3 for all x belongs to the real numbers. Show that f is invertible. So here first of all we have to check whether the function is 1 to 1, then only it is invertible. Invertibility is possible. So f of x1 is equal to f of x2 in the sense 4x1 plus 3, 4x2 plus 3. So x1 is equal to x2. So this is a function is 1 to 1. So it is invertible. So now you have to give your data. F of x is nothing but y, 4x plus 3. So solve for your x value. So y minus 3 divided by 4. So now f of x, that is f of y minus 3 divided by 4 which is equal to 4 times y minus 3 divided by 4 plus 3. So cancel, cancel. So y minus 3 plus 3 which is equal to y. So left side is also y and right side is also y. So f is on to. So thus you have to write your data. Thus f is 1 to 1 and therefore invertible. Read this question. Set A is a real R accepting the value of 3 and for B exceptional value is 1. So function is given as A to B and f of x is given as x minus 2 by x minus 3 for all values of x belongs to A. Input is our A, output is our B. So that f is 1 to 1 and on to. So first check for your 1 to 1. So f of x1 is equal to f of x2. So our data is x1 minus 2 divided by x1 minus 3, x2 minus 2 divided by x2 minus 3. Do cross multiplication and then simplify your data. So x1 minus 2 into x2 minus 3 is equal to x2 minus 2 into x1 minus 3 and proceed your data so that you will get minus 3x1 minus 2x2 is equal to minus 3x2 minus 2x1. So now minus x1 is equal to minus x2 so that you can write your value x1 is equal to x2. So our function f of x is 1 to 1. 1 to 1 or you can say it is injective. And for onto function or subjective, so you have to check y is equal to x minus 2 divided by x minus 3 and solve for your x value. So x is equal to 2 minus 3y divided by 1 minus y. So x is equal to 3y minus 2 divided by y minus 1. So this data belongs to the set A. Look at your data. A is exceptional with 3. That is fine. And for all values of y belongs to B. That's all. So our f of x function is on to. So now you can, even though the question is not asked, so here it is satisfying with 1 to 1 and on to, so that you can say f of x is bijective in nature. Show that the function f r to r, real number to real number, f of x is equal to x power 4 is neither 1 to 1 nor on to, we have to prove. So first go with the data. F of minus 1 is equal to f of plus 1. So function is x power 4. So minus 1 to the power 4 plus 1 to the power 4. Both will be equal to 1. Whereas minus 1 is not equal to plus 1. So the function f is not 1 to 1. And coming for the next one. So here the data is x power 4. Function is x power 4. So you can supply your x power 4 value of x power 4 lies between 0 and infinity. So in this case the range is not equal to the codomain. So our function is not onto. Proved. Now read this problem. The function minus 4 to plus 4 to 0 to 4. So input is minus 4 to plus 4, output is 0 to 4 is given by the function f of x is equal to root of 16 minus x square, that is nothing but our y. Y is equal to f of x. Show that f is an onto function but not a 1 to 1. So first we will prove for onto function. So y is equal to root of 16 minus x square. So here the y value is greater than and equal to 0. So you can get your value as range. Here the range value is 0 to 4. Look at your data. This is 0 to 4. So this is equal to your codomain value. So the function is onto function. We have proved first. But not an 1-to-1 function. Second half is not an 1-to-1 function. So for 1-to-1 function, you have to prove f of x1 is equal to f of x2. So now take minus 1 and plus 1. F of minus 1 is equal to f of plus 1. And according to the question, square root of 16 minus x square. So that is root of 15. But here minus 1 is not equal to plus 1. So function is not 1-to-1. And third part is here find all the possible values of a. For f of a is root 7 it is given. So use that value. f of a is equal to root 7, that is root of 16 minus a square, that is root 7. So a is equal to plus or minus 3 here. So here this value we can find our possible values of a. Sorry, here it is 9, root 9. So plus or minus 3. Look at this problem. Show that the function f input is defined with minus infinity to 0, output is minus 1 to 0. Defined by the function f of x is equal to x divided by 1 plus modulus of x. What about our x here? It is minus infinity to 0. Then modulus of x will be minus x. So our f of x is now x divided by 1 minus x, because x belongs to minus infinity to 0. That is why we are writing like this, our f of x function. So now check for your 1 to 1 and on to. First go with 1 to 1. So f of x1 is equal to f of x2 we have to prove. So x1 by 1 minus x1, x2 by 1 minus x2. So do your cross multiplication. And then simplify your data. So x1 minus x1 x2 is equal to x2 minus x2 x1. So x1 is equal to x2 here. So our function f is 1 to 1. Now checking for on to. So y is equal to, what is our function? What we have defined? Y is equal to x divided by 1 minus x. So x divided by 1 minus x. From this, solve for your x value. That will be y divided by 1 plus y. So look at your data. Here our y value is defined. Output is defined for minus 1 to 0. So y belongs to minus 1 to 0 in this problem. In the here we can define all your x is defined. So our x value given in the question. X value is minus infinity 0. X value is defined for all values of x. Sorry, all values of y. So you can say your function is on to. That's all. Read this problem. Show that the function is given with natural number to natural number, where n is a set of natural number and f of n is given n minus 1 if n is even and n plus 1 if n is odd. It is bijection. Bijection in the sense 1 to 1 and on to we have to prove. So if I am doing like this, f of x is equal to f of y. Say if both x and y are both odd or both even, then n minus 1 or x minus 1 or y minus 1. This case x plus 1 is equal to y plus 1, or we can say x minus 1 is equal to y minus 1. So in both the cases our x will be equal to y. So this is function is on to in this case. But here we are considering both x and y are both are odd or both are even. But if you consider your data, if one is odd and other one is even, if x is odd and y is even, okay, in that case, or other in the reverse also, y is odd and x is even. So in that case also you can have your data x plus 1 is equal to y plus 1. So here x minus y is equal to, what is your data? X minus y. Here this data is, sorry, y minus 1 left. So here we are having y minus 1. So this case is x plus 1, y minus 1. So x minus y is equal to minus 2 in this case. Look at your data. If one is odd number, other one is even number. The difference between the odd and even is here it is coming as differ by 2. But practically that is not possible. So we are not considering this condition. X one is odd, other one is even. So we consider only this part. If both are odd or both are even. So in that case, we got x is equal to y. So our function is 1 to 1. And coming to the next part, on to function. So we know f of x is equal to y and f of x is y. So this gives, so we can write our function as x is equal to y plus 1. Or you can write x is equal to y minus 1 in this case. So if one is odd, other one is even, then what will happen? If y is odd, then x is even. If y is even, then x is odd. That is the case. So here the range will be equal to our codomain value that is equal to the natural number n. So you can say the function, given function is on 2. So both are satisfied, 1 to 1 as well as on 2 is satisfied. So our function is bijective. So you can declare your answer f of x, the given f of n. This function is a bijection function. Meet you in the next video. Bye.